I think I have the first agenda item, but my screen is a mess. I lost the agenda. I have the only agenda item. Okay, I'm going to share my screen. I wanted to talk a little bit about some work that we've been doing that led to this graph. This graph is the timeline forecast for Redis Psychic, Redis primary CPU, and we have a very nice forecast, which is actually a different issue. I keep wondering when timeline will catch up to the fact that it's stable at 40%, but the answer is it hasn't. But what I want to talk about is how we got here and what happened. And this kind of happened bottom up. There were a couple optimizations we found, and we just started doing them. And then at some point, I realized I should make this an epic. So there's actually an epic for it, but it's just to put those two issues together. Um, and I think there are some interesting lessons, or I learned some interesting lessons from this, and I want to share those. So what the two issues in the epic are do something about Psychic cron and do something about duplicate jobs because they both use Redis a lot. And this stood out because of looking at the Redis commands duration counters, which show time spent in the main thread of Redis in the handlers of in the request handlers. So for Redis Psychic, that was showing that the top commands were exec. That's this one, and then the green one is hgetall. And when I saw that, I thought that's funny because neither of them is about pushing jobs, and Redis Psychic is for pushing jobs to Psychic processes. So that looked funny, and I think Igor then did a traffic capture to figure out what the hgetall was, and that turned out to be the fault of Psychic cron. And then Alejandro worked on changing how Psychic cron does its polling. So Psychic cron does cron jobs, and every Psychic process periodically checks the list of all cron jobs to see if they need to run. And that code was written in a silly way where we would poll way too often. And that's so the actual rate of these hgetall commands was very low, but they were quite expensive and they happened too often. So when you see this drop, that is where the hgetall commands went away. And then the other thing, the exec calls were caused by the way the duplicate jobs middleware is using Redis. And we had a couple false starts with feature flags or making changes after we iterated a couple times. And then from this point on, that workload is gone. Any questions so far? Some of you have known this was going on at the time, so it's not new. What I found interesting here is that of the two, the duplicate jobs change seems to have had a bigger impact. And if we look at the CPU graph, so October 25th, roughly, that's about here is when the hgetall change happens. So here we were peaking at 60, and here we started peaking at 55 or something. And then duplicate jobs went away, and then we went to about 40. So this was roughly a 5% drop, and this was roughly a 15% percentage points drop. So the drop was bigger, even though looking at the graphs, they were not, you wouldn't expect one to be a 3 times bigger
But
drop than the other.
the hgetall, as you mentioned, most of the time didn't do anything. So it was just a lot of them, but
Well, I
supposedly they
actually
don't.
think the answer is different because here I have a graph of the request rates. And here you can see October 25th, there's a drop in the request rate because of the hgetall, but the drop because of duplicate jobs is much bigger. because here we see that the total Redis request rate is peaking at around 20, and here it was around 40. So apart from the time, and this is one of the,
Because it
if
was
you think about,
multiplied by the number of jobs we execute.
yeah, exactly, because every job does this. That's why there were so many requests for this. So even though these graphs were about the same height, this is the duration again. The green graph was caused by a relatively small number of requests that took a lot of time, computation time on the main threads. But because the number of requests was low, the per request overhead was also low. And these were not necessarily that computationally expensive, but there were just a whole lot of them, and they were individual requests.
Right.
So
So I guess I think not shown on this graph is the actual I/O processing time, so the system time effectively.
yeah, exactly. That is, I forgot to pull up a flame graph. I don't know, so I can quickly find one. But if you would look at a flame graph of, okay, I can't say this without getting a flame graph. I'm sure I have one somewhere.
I mean, I think one other thing that we could look at is the CPU utilization on the main thread broken out by mode so that we can see user and system time and see if
Right.
we see that corresponding drop in system time.
So this is, for
Potentially.
people who don't know these graphs, this is a typical, what you typically see when we capture a perf CPU profile for a Redis process. Igor knows this very well. And what is weird about this is that most of this is I/O. So this is write I/O, this is read I/O, and the actual computational workload of what you think Redis is doing, or what Redis is doing in user space, is this small part. And the graph I have here, which shows the durations, is only measuring in here, in this block, but it's blind to what's happening here and what's happening here. And what is happening here and here is proportional to the number of requests we do. So another way of explaining this is to say that because the duplicate jobs workload also did a lot of requests, it accounted for a large part of this and this. So it shrunk this and this tower. And for me, it was an interesting, like when I say looking back, it seems obvious, but it was an interesting reminder of the, yeah, of the different effects of, and also of how to choose what to work on. So because the simplest way to explain what we did with duplicate jobs is just do fewer Redis calls, which is a very simple metric to optimize for. Yeah, that's what I wanted to share. And hopefully at some point this thing will stabilize, because it's not really going to stop.
Do you know about when we introduced the the cookie? No, not the cookie stuff. The separate wall locations where we store wall locations next to the duplicate jobs. And do you know how come we didn't notice that at the time?
Okay, I need to fill in the rest of what we're talking about here. Duplicate jobs sets, the middleware was originally written to set just one or two keys. And then at some point, another team worked on database load balancing for Sidekick. So every job carries wall locations in its metadata, so that it can so that it can be sent to a Postgres secondary that is up to date with those wall locations. So the idea is to send as many Postgres queries to secondaries as possible. And for that, you need to know in the context of a job or a request, like how up to date your Postgres has to be. So this was added later to the duplicate jobs middleware, and this was where most of the extra requests came from. I don't remember when the code was added, but another funny thing here is that the load balancing was actually not being used because there was a bug in how the data got consumed. So we still had the overhead of the load balancing code in the duplicate jobs middleware, but we were not using it. And we found the bug that caused load balancing to not work then because Bob remembered that and he pointed me at it, and I happened to see it because I ran into the same bug more or less when working on this project. I think now we have other bugs with load balancing,
I
but
was just about to say.
that's a separate story. I'm not sure we can say it's 100% working now, but it was really not working before.
Well, now we're reading from replicas, just
Yeah.
maybe not always the right one, or like, yeah.
I don't know when that code got added, and I have one graph up with a 1-year view. Or another thing you can see here is that we, for a
That's right, we
while,
briefly moved it to shared state.
moved duplicate jobs to shared state, and that was a bad idea. And the funny thing is actually that here we were not doing duplicate jobs, and here we are doing duplicate jobs. So the optimizing them was worth it. But where in this period the load balancing got added, I don't know. I don't see an obvious
I think it
jump.
might have been longer ago than.
It might, yeah, or it might have been longer ago. Yeah.
But the reason I ask is that ideally we'd respond to things like that quicker, so we have like, so normally we would have seen that because capacity planning would point it out or something else. So we
Well,
can try
I
to figure
suppose we
out what
see it if we
changed.
cross a threshold, but if the like does capacity planning work with an alerting threshold or with the
issues
rate at
like
which we're growing?
the rate at which is growing, like if you have, like if we're at the like let's say we were at the 40 before and then this got added and it jumped to 60, then the prediction would have or should have
Would have temporarily said we're going to run out of
yes,
capacity
and
in
then
X days, and that would have caused an issue.
like
Yeah.
so my hope is that you were going to tell me that we did this 2 years ago and we didn't have capacity planning, but yeah,
I
I'll have
don't
to look
know.
it up.
How long have we had capacity planning like this?
This year, I think January-ish.
Yeah. We can probably, I could look in the commit history when the database load balancing got added to the middleware, but I don't think I'm going to
I
do
can
that
also
now.
do that.
Yeah.
No problem.
Okay. Thanks everyone. I was looking forward to sharing this.
You want to touch on your last question? Should we remove the
Oh,
plumbing that we did? So we already tried to move this workload once. We moved it to shared state, and that was a bad idea because shared state was more closer
I
to
can
saturation.
illustrate that for you, Bob. If I share again, if we go to Tamland, this is where we moved duplicate jobs to shared state, and we made plumbing for that to be able to move the workload. And if you see, this is the second half of July, and then we go to Redis persistent. Then we're here, and that was bad. And I wonder if this is because we did duplicates rights, because it starts early.
Yeah, we did that.
Starts a week early, and
We did that. So we started writing and
yeah,
reading if possible, but doing it on both things. Then yeah.
yeah. So we backed away from that, but the code to make that data migration possible is still in there. And I saw it the other day. It even still has the feature flag. And I thought, when do we decide that we're not going to do this and we throw this out?
Do we decide that we're not going to do this? Because it was my understanding, and even from what you just said, we would expect Sidekick Redis to only do Sidekick, like actual, like the things that come from the Sidekick process gem,
Mm-hmm.
yeah, on the Sidekick Redis instance.
So the argument is it doesn't belong on Redis Sidekick.
That's the question, I think.
Yeah, well, I think it doesn't belong there, but I'm not sure it's worth moving. At least not at the current.
Well,
I think the reason this work got scheduled is because of Sidekick zonal clusters. Because duplicate jobs would have to work correctly across zonal clusters, so they couldn't be.
yes, so they needed to be on one of the shared Redis instances.
Yeah.
But now that all the plumbing is in place, should we do the migration and then remove it? But there's no point in doing it now,
But
as the
the
graph on your
plumbing is,
screen shows.
yeah, and the plumbing is built to move it to shared state, which is not in the best shape. So I wouldn't want to move anything to shared state.
No, but
I want to move
the
things
plumbing,
away from shared state.
the plumbing that is there has one of the, like has GitLab Redis shared state, and we can just replace that with something else.
Okay, we could
Yeah.
point it at something else. Yeah.
Yeah, so that's a very small change. But then the question comes why? Like the graph shows that we don't really need to, and I don't think we'll be looking at zonal clusters anytime soon because of the graph you're showing. So
I think I'll just make a merge request to remove it, and that then.
if you threw it my way, I'd probably merge that.
So maybe I need to find out who doesn't want to remove it and then let them review it so we can have a discussion about it. But that person is not in this call because I'm not hearing them. Thanks for remembering or noticing that I forgot to ask one of my questions, Bob.
Your turn, Igor.
Yeah, so I've been working on Redis cluster cookbook this last week, and we have a first working setup on pre. So I just wanted to give a quick demo of that. Here we go. So the naming scheme that we've gone with, and we can change this if needed, is Redis cluster rate limiting. So this is the type, this is the name of the service, so to speak. And then shard 01, and that's 01 through 03. And then each shard has 3 nodes inside of it. So there's sort of 3 zones per shard. And so this is running Redis 7, a custom build of Redis 7. And we've implemented a GitLab Redis CLI helper script that finds the right secret so that you don't have to always remember this stuff. So we can do ping. One new addition is that this actually supports multiple users. So I can, this was added in Redis 6. And so we can say, who am I? So this is the console user, and I think there's ACL list, which I'm not sure if this just leaked our passwords. Maybe.
Yes.
We can rotate it if needed. But yeah, in any case, yeah, I'll rotate it after this call. So yeah, we've got like a console user, a Redis exporter user, a replica user that's used by the other Redis nodes to talk to this Redis node. And so we get a little more fine-grained access control. But what I actually think is more useful than that is potentially ability to rotate these passwords, which currently is pretty difficult to do. And also attribution. So I don't know if all log lines include this information, but the hope is that if something weird is going on, we may be able to tie that back to the user. So then we can run some Redis cluster specific commands. So here's the -- cluster info. And so we give it, you need to give it a node, a Redis cluster node. And so I'm just going to give the same one. I could also put localhost here if I wanted to. And the display here is a little weird. So in some cases, it uses IP addresses. In some cases, it uses host names. This is just Redis CLI being picky about when to show host names and when not. But behind the scenes, it's using host names for all of this stuff.
It's host names on the wire.
Yeah. And so we can see there's a single key so far. And let me try and remember what the command was. So I think it was Redis cluster. Well, actually, we can call cluster help, and this should tell us there's a call command, and we can give it host port and then command followed by arguments. So we could. I'm curious if this is going to work. We could try and do the naughty thing, which is cluster call keys. Don't do this in production. Interesting. I would have expected to see a key here. So I don't know if the keys command just doesn't work in cluster. So we could try instead of keys. I think was it foo?
Why does it say snap?
I don't know.
It looks to me like some shell script somewhere is seeing snap.
Yeah, you're right. You're right.
Because that's an Ubuntu
snap
command, right?
Yeah, I think snap is a directory that I have here. Yes. Oh, snap. Yeah. So
so if you make a directory called keys star or a directory called star, maybe then it works.
I'm not sure I want to do that because then I'm going to have to remove it. And removing
RMRF star.
Yes, seems a little scary. Yeah. So yeah, to do for me, figure out the correctly passing arguments to this, or I guess, yeah. I mean, I did quote it here, so there is some additional thing that needs to be fixed. Well, in any case,
I would suspect that it is GitLab Redis CLI a shell script?
It is.
Then it's probably a quoting problem in there.
Yeah, yeah. I can. Yeah, I'm gonna fix it later. But in any case, so I can do get foo, and I know that this is a key that exists, and we can see, okay, most of the hosts responded with moved, and then the slot, and then the owner of the slot, and then one of the hosts actually had that key and gave it back to us. And so, we can say increment request count. And we can sort of see that counting up. And yeah, that's pretty much it. That's kind of where we're at. And I guess the next step that we're working on right now is getting the clients configured to actually talk to this instance. So that's going to be GitLab Helm chart updates. Yeah. Any questions or comments?
How do you want to see like observability dashboards and stuff on a Redis cluster? Do you want to see, like I'm assuming that you want at least one aggregate of the entire cluster thing? The reason I'm asking is because I bogged down on the name, so the first sentence you added, and then you've got the cluster, so the cluster name in the beginning, and then shard 1 to 3.
Yes.
Or 0 to 2, I don't remember.
No, 1, 2, 3, yeah.
So I'm wondering, should those be called shards or not? Because there's also an issue where we want to combine all of our Redis instances, and each Redis each thing that we currently call a Redis instance would be a shard. So we have the service is Redis, and the shard is rate limiting sidekick cluster.
Yeah, so I was thinking of repurposing the shard label, which would kind of block that other idea that you just mentioned.
That's why I'm asking.
But I think that might actually be the right call. So keep one service per Redis, and then use the shard for the actual Redis cluster shards.
The alternative that I thought about while you were talking is using Redis cluster as an alternative service, shard as each shard in there, and then that dashboard needs to be different so it accommodates for the different shard, like the different
right, but then we need like a deployment, an additional deployment label or something
like that.
Yeah. I think the easiest thing to do right now and most consistent with what we're doing is Redis cluster rate limiting as the type, the service name, and then repurpose the shard label with a numeric shard. That's kind of what I'm proposing at this point.
I think that makes sense. Like, we need to do a lot of migration anyway. Like, if we want to change it, it's a lot of migration.
Well, is it possible to, I don't know how fixed this is, but the way the presentation suggests these are 3 separate things that happen to be collaborating in Redis cluster. Although from what I know in Redis cluster, it's actually 9 things. And if you would let Redis cluster do its thing, they would move all over the place. So you're using a config setting to prevent that. But if we think of them as 3 separate things, we could also have 3 separate dashboards. And then they would sort of look like Sentinel deployments. Would that be a way to, because I think ultimately you want a dashboard that understands cluster and that can show things that are about cluster and that can show things that are about instances. And I understand that we don't want to maybe not immediately make that. So as a hack, we could say that these are 3 things, and I don't know what to call them, but 3 kinds of
shards.
Are they called shards?
Yeah.
I don't know, whatever shared state and sidekick and trace chunks and rate limiting are, 3 of those.
Oh, I see. Okay.
And then we happen to know as humans that actually they are collaborating in a single Redis cluster.
Yeah. So you would kind of go ahead. Yeah.
I would say I just suggest we just call everything shards, and that way the problem is resolved. Just everything.
Yeah. Also, everything is a cluster.
Sure.
Sentinel cluster, Redis
shard,
cluster,
instance, node.
worker.
Ooh, I like that.
Service.
I only had snark to add, so go ahead, Igor.
So what I would like to see, and maybe Bob is going to yell at me because it's hard to do, is have a shard selector on the
I want that as well.
On the dashboard.
The service overview, and then you can select all of them, or
and have one that is just all of them, and then you can drill down to the specific one.
I'm not going to shout at you. I want that.
But aren't we? I wonder if we can both. So what Bob means by shard is the Redis, the Sentinel deployments we have now, and what Igor means by shard is the individual masters within the Redis, this one Redis cluster deployment. But if we say that we treat these individual masters and their replicas like individual things, and we just forget for a moment that they're joined together in Redis cluster, then you're both talking about the same thing again.
In terms of ergonomics, having to check 3 dashboards is not so great.
No, but that's why you really want a Redis cluster dashboard. But you'd have to make that anyway, because you need different panels in there.
Yeah, but you can add anything to a service dashboard. It's just where you start. But so you can, like we made our Redis overview dashboards Redis aware and our Sidekick dashboards are Sidekick aware, we can add whatever we want to the Redis cluster dashboard. And then if we continue down the path we're currently doing, we'll just end up copying that dashboard to a million different services that we call, that are instances of Sidekick cluster. Oh, this conversation is hard. But I think I agree with Igor for now. Like, we have some things that are already correctly using shard, and I'm thinking about Sidekick. That's a deployment, and each deployment is a different shard. And right now, the only thing, like the way we can see different shards is because we've adjusted the Sidekick dashboard to include some panels and because we link to different dashboards. But it would be way handier if every Sidekick shard had the same kind of SLIs, which is like throughput of jobs with whatever.
Wait, what are
properties.
Sidekick shards now?
Catch-all, low urgency, CPU bound.
Okay, so they're roughly job queues.
They're queues.
Yeah, okay.
Yes.
And this goes back to what are shards?
But that's what a shard is in Sidekick. And now what Igor is proposing, and I'm kind of on board because that's where we are now, is using adding a new Redis cluster rate limiting service and using the three groups of three Redis servers below that as a shard. So every Redis cluster service would have 3 shards.
Or more in the future.
Or more.
But at least 3, yeah.
At least 3 shards, got it. And for that, you're going to add the shard label on top of the service dashboards. And I would reuse that for Sidekick. So go ahead, go for it.
Okay.
I like that.
Yeah, I mean, one of the motivations there is we already include the shard label in almost all of the aggregations. And so there's hopefully not too many places that we need to touch to pass that through.
Are we using the shard label for that many aggregations? Or is it just that we don't have the shard label very often?
Yeah, I think we don't have it a lot. But all of the generic aggregations, I think, do include shard.
Yeah, it looks like you're right. Cool. That's reason enough to go with that, I think.
Sweet. I think that's it. Anyone else have anything else they want to demo or talk about? I'm calling it. Thanks, everyone. Have a good one. Bye.